Alrighty, welcome to lesson 4 and 5. In the last couple lessons, you were introduced to how to represent function notation as a way of describing our functions. Today, we're going to take that a step further, and we're going to look at how we can describe functions using rules. And so this is actually going to connect a little into our equation unit from the unit before. And so our goal today is you can write equations that represent rules of function. So over the past couple of days, we've been using descriptions to describe rules, right? The time versus the distance from the dog and the post, and all of those relationships. And now we're going to quantify that rule using a algebraic representation through equations. And so the first part is to start connecting that idea with a table, right? What do you notice and what do you wonder? What do you see from X? What do you see as a result? As always, one thing you notice, one thing you wonder. Do not tell me that there are 2 tables. Do not tell me there are 4 entries in each table. That is obvious. The goal is to really think slightly deeper. What is the relationship between both of my columns? What is the relationship between my columns here? Talk about what you really see and what's going on. And so the first activity connects the idea of our understanding how we can make sense of our functions using function notation and equations. And so in this case, we start off with our verbal description. And so here we have a representation of 4 linear functions. Linear functions are represented by a line, things we've been talking about before in Unit 2. And we have 4 descriptions. And so you want to connect your descriptions to your equation. And so something that, as a reminder, this x here, my x here represents my input. And this entire expression represents my output, right? F of x here represents my output, right? F of x is my output. And so you want to create a rule, match a description to that rule. And so, for example, if I want to get the output of my get my algebraic representation to match with my description, right? We can take a look at the first one, right? To get the output, to get f of x, I need to multiply the input by 3, then subtract 7 from the result. So I know that my output here is f of x, and my input here is x. So I want x multiplied by 3, so I want 3x, and then I want to subtract 7 from the result. I know that that should be equal, this result should be subtracted by 7. And so I know that all of this results in my output. And so this is how I can connect my description to my equation. And so do the best to do the other 3 as well. And then take a look at how we can use those equations to describe relationships with our functions. And so for one of the equations, when I input 6, when x equals 6, the output is -3. And so the question is, which function is that? And so if I know my input is 6, and you can write a table out if that is easier for you. If my input is 6, what happens when I have f, when I have g, when I have h, and I'm going to run out of space, and when I have k? Right, what is happening here? Let me write that a little bit neater. If I have my x, I have my f, my g, my h, and I have my k. And so, right, I can have an extended table. If I know my input is 6, what is my output for each of these values? So if I input 6 into my equation, right, my input, remember, represents my x. This gives me f of 6, right, because I'm substituting that value in for all x's that I see. This gives me 3 times 6 minus 7. 3 times 6 gives me 18. 18 minus 7 gives me 5, right? 18 minus 7 gives me 11. Sorry, I was like subtracting the wrong way. 18 minus 7 gives me 11. And so I know that when I input 6 in, my output, my rule, my result is 11. And so try that for each value, and your goal is to get an output of -3. So which equation, obviously you know it's not f, gives me a result of -3? And then you want to compare and see what happens with when your output is 0, when your output is 10. And so today this lesson really starts to build on our understandings of our relationship and our rules between our inputs and our outputs. Like, for example, the square has a side length of 7 centimeters and an area of 81 centimeters, right? If I have a square, think about your squares. Square is a length of 9. I have an area of 81. Remember, area for a square represents our side length squared. I know if I want to find the area of this, I know to do 9 times 9, which gives me 81. And so we want to represent the relationship between the side length and the area as a function. So listen to what I was saying verbally, and first complete the table, and then represent that writing a rule. And the last part is you want to start connecting that idea to a graph. And so if I have my coordinate plane here and I want to sketch a graph of my function, remember your side length, your x-axis always represents your input. Your area, your y-axis represents your output. And so if I wanted to plot the lines here, if I have 4, 16, this gives me this point right here. I'll make that a little bigger so you can see it. This gives me my point right here. And 981 is a little bit off of my map, but you want to start building your graph by going through each of those points and then connecting those values. And so start to build that connection between how can I represent our my function in multiple ways, right? The top left, I have a table. My bottom right here, I'm going to have my top right, I have a table. But my bottom left, I have a rule algebraically that you yourself will write down. And on your coordinate plane, you're going to sketch your graph. So these are all 3 different representations of functions as well. And so I want you to continue to do that when it comes to lesson 5.2. Right? Look at your 2 options. What does A of 1 represent? What does B of 1 represent? Right? If I substitute 1 into my equation, I have no x to substitute, so this is very straightforward. For B of 1, I know that to substitute 1 into all of my x's, right? And this is going to give me a value of 10 plus 25, which gives me a value of 35. And so do the same for the second one as well, and then start to think about how can I apply that idea, right? How can I describe each of these plans using words? Remember your description. Descriptions also can come back to what you were talking about in slide 3 as well. So one step at a time, right? Think about your verbal description, think about your algebraic representation and how you can represent that using a graph. And as always, think about what it means in your context as well. And you're going to finish that up with taking a look at what happens when you have a graphical representation of your function and how you can represent it using a graph, a algebraic representation, and using the table. And you'll see something cool as you're going along. When you are writing entries into your table, right, use the table to find B of 6 and B of 2.5. You can just go to the bottom here and just add a 6 and add a 2.75, and you'll see what changes once you add B of x to your top here. And if you want to estimate, remember 93 here represents your output. So if I'm looking for my value at 93, you want to look for when your output or your y value equals 93 and how you can see that with your graph. So you can just trace your line, or you can find it using your table. So I'm just trying to teach you how to connect all those representations together and how you can use that to be successful in our function representation. And as always, if you're stuck, take a look at our lesson summary. This gives a rule, this gives your table, this gives your graph, this gives you another example as well. So I will see you in lesson 6.